So take a look at the topic at the top of this page of the packet. Quadratic roots. One of these words should be familiar. Which one? Quadratic. We talked about quadratics all week last week. So help me remember what we know about quadratics. What's one thing we know about quadratic functions? Anything? They're symmetrical. What'd you say? They have the shape of a parabola. Great. That's kind of like a bowl shape or a U shape, either up or down. Great. Mason mentioned they're symmetrical. Does anybody remember, what do we call the point where our parabola crosses the y-axis? Y-intercept. What do we call the point where the parabola crosses the x-axis? X-intercept. What's the name for that special point right in the middle of the parabola? I think I heard different versions of it. There are different names for it. Vertex. But if it's on the top, that vertex is a maximum. If it's on the bottom, minimum. Okay, I get it. We all took our brains out over the weekend and gave them a bath. We washed out all the math from last week. I'm just trying to get you thinking about some of the things we know about parabolas. Because today we're going to get a new definition, and this one's really important. Roots. The roots of a quadratic function are the x values that make y equal 0. The roots of a quadratic function are the x values that make y equal 0. And I need your guys' help to decipher this. So I would like a volunteer to help me out. So the roots of a quadratic function are the x values that make the y value 0. Think about what that means. If our y values are 0, does that remind you of any concepts that we've talked about recently?
It's got to be like...
I'm not just going to give you the answer. I'm going to make you help me figure the answer out. Okay, well, let's talk through it. So here's our graph. All right, think about this, Miles. The definition of roots has to do with where y is 0. Think of a point that has a y value of 0. Any point you want. Yeah, right in the middle. So this is the point 0, 0. Think of another point that has a y value of 0.
Right to the right, one space to the right of it.
Yeah. Okay, think of another one. This should be easy.
One spot to the right of it.
One spot to the right. All these points, right? And we could go left too.
Yeah.
All of these points that I'm drawing have a y value of 0. What do all of these points have in common? Where are they located?
On the x-axis.
On the x-axis. See, you guys can figure this stuff out. On the x-axis. Roots are always located on the x-axis, and this belongs in your notes. So we have another name for this. We talked about it last week. In fact, I just kind of drew a picture of it a few minutes ago. The roots are the points on the x-axis. What else do we call these points? I heard it. Say it louder. X-intercepts. Exactly right. So down here, we have a bunch of blanks to fill in alternate names of roots. Roots are also called x-intercepts. So this is not a new concept. We talked about this last week. You guys know this stuff already. This is review. All we did was we learned a new name for a concept we're already familiar with. And we're going to learn 2 more names too, because roots go by 4 different names. You can call them roots. You can call them x-intercepts. You can call them zeros. Or you can call them solutions. These all mean the same thing. So when you're doing examples this week, some problems might say, find the zeros. Some problems might say, find the roots. Some problems might say, find the solutions. It all means the same thing. So take a look at this picture. Different quadratic functions might have a different number of roots. So I'm going to ask for your help in figuring this out. Look at the graph A, the graph B, and the graph C. Can someone volunteer to help me figure out which of these graphs happens to have two roots?
A.
Okay, A has two roots. Miles, you said it first. Can you explain to me why or how you know that A has two roots?
Because it goes on the x-axis 2 times.
Thank you. It crosses the x-axis 2 times. So for graph A, we're going to say this has two roots,
Bro, quit touching my.
which is the same thing as saying this has two solutions. So you could say it either way. You could also say it has two zeros. Okay, can I get a different volunteer to tell me how many or which of these graphs has one root? C. I heard Maddie say it first. Why does C only have one root? It only touches the x-axis one time. So we would say this has one root or one solution. They mean the same thing. Okay, so finally, can I get a volunteer to explain to me what's going on in B, in graph B? Logan, how about you give it a try?
No solution.
Yeah. There's no root, no roots, no solutions. And Miles explained why. Can you say that one more time? Because it never touches the x-axis. Exactly right. Okay, so we get this. You guys are doing great. This concept seems like it's coming pretty quick to you. So now let's talk about not just identifying how many roots we have, but in finding the exact roots. Before we do that, I do want to remind you of something from the definition. Roots are x values. So I know typically in the past when we talked about x-intercepts, we tried to find the point, the x comma y. But we're not interested in doing that anymore. Now we just want the x value. We're just going to find the x value. We don't care about the y value because the y value is always going to be 0. So that's boring. So we're just going to use the x value as our answers here. And you'll see what I mean with an example. Example 1. What are the roots of the quadratic given by the parabola in this picture? So it's going to be hard to see on the screen. You might want to look at your paper instead. So what are the roots of this parabola? Or how can I find them? McKenna, what do you think?
It's 2, or I guess 1.
It is 1. This is a
-4.
exactly right. So pay attention to the scale, but McKenna's looking at the exact right spots. We're looking for the places where our parabola crosses or touches the x-axis, and we're only concerned with the x value of those points. So the one on the left is -4, and the one on the right is 1. So we have two answers, -4 and 1. It's really that easy. So when you're given a graph, when you have a picture to look at, it is not going to take you long at all to find your answer. All right, take a look at number 2. Number 2 is a little different. In example 2, we are given, instead of a graph, we're given a table. I need somebody to help me brainstorm how we can find the solution when we're given a table. Can I try to get a volunteer who hasn't spoken up yet today? Maya, you want to give me some help on this one? Okay, so let's think this through. The definition of a root, what's the important part from that definition that you underlined? Y is 0. So looking at this table, what should we be looking for? On the y values, exactly. So I see that in a couple of places, but is that our answer? So what should our answer be here? So I see what you did there. Can you explain it to the class?
Because it goes on, like, if y was 0, then the x value would still be different.
Exactly. So find the places where your y values are 0, and it's those x values that are the roots. So our roots here are, whoa, I just closed all my windows. 1 second. So find the places where your y values are 0 and then use the x values associated with those. So our two x values here that are our roots are -2 and 0. So thank you, Maya, for helping us with that problem. In examples 1 and 2, we did that really fast, right? It did not take long. When you're looking at a table, when you're looking at a graph, picking out your roots is relatively easy. Let's take a look at example 3. In example 3, we don't have a picture, we don't have a table. How in the world are we going to find the answer to this? How are we going to find the roots of this function? You probably don't know the answer because I haven't taught it to you yet. There are methods to solve these, but we're not going to learn them until after spring break. What we're going to do this week is we're going to solve these by using our calculators. So these calculators are extremely robust little computer machines that can draw graphs for you and they can make tables for you. So all we're going to do is we're going to take this function and we're going to turn it into a graph or we're going to turn it into a table, and all of a sudden you have a problem that's just as easy as example 1 or example 2. All right? So here are your steps. Turn your calculator on. Everybody. Okay, so you got your calculator on. In order to use the graphing features of the graphing calculator, we have to first enter our function. That happens right here by clicking the y equals button. So it's the top left button on your calculator. Click the y equals button, and that's going to open up a menu that looks like it has y1, y2, y3 on the left-hand side. If there's anything else written here, you want to erase it. So kind of go through the different menu items and erase any function that's already been typed into these lines. Once you're looking at a clear page, we enter our function on the first line. So go up to y1, and we're going to type in our function, which is just this part right here. The x squared minus 4x minus 12. And if you're wondering where to find the x button, that's located right here, just to the right of the green alpha button. So it looks like it has an X and a T and a theta and an N on it. It's just to the right of the green alpha button. So we're typing in x squared minus 4x minus 12. And if you're done typing it in, I want you guys to look up at me so I know who's done and who's still working. Now that you have your function typed in, what you're going to click is on the top right of your calculator. It's the button that says graph. So you type in your function, you click the button that says graph, and all of a sudden, you should be looking at a picture of a parabola. Now, this is what mine looks like. So my screen looks like this, and my parabola kind of goes down about like this on my screen. Is that what yours looks like?
No.
Okay. The
I don't even
reason,
have a parabola.
so some people are saying yes and some people are saying no. The reason is because we all might be looking at a different window. So remember, a graph goes on forever in both directions. So some of us might be looking at just a generic sized window. Some people might be zoomed way in. Some people might be zoomed way out. So everybody's images might look different right now, and we're going to fix that. In the middle of this row, there is a button that says zoom. Click zoom. And if you go down to the 6th line, it says Z standard. That means zoom standard. Zoom standard is just sort of the generic zoom window that it's supposed to default to. And that would be from 10 to -10 in every direction. So if you hit enter, so click zoom, scroll down to zoom standard and hit enter, Your picture should now look like my picture. Does everybody's picture look like the picture I drew up on the board?
Yeah.
Okay, so look at this picture. Can you see the roots? Yeah. So use your eyes, count the values, and let's find our roots. Can I get a volunteer to tell me what one of my roots is?
6, 0.
I see the 2 is on the left, so that's -2. And then I heard somebody else say the other number? 6. Goodness. So our roots are -2 and 6. We can just see that right here on the picture. And there are all kinds of cool things you can do with this image. We just experienced the zoom button. You can click that again, and you can go down to zoom out and hit enter a couple of times. That'll zoom you out so you can see the full parabola a little better. You can zoom in if you want to get a really close look at something. So these calculators give you a visual of what your parabola looks like. The coolest thing is, though, they don't just give you a graph. They also give you a table. So now we're going to talk about the second thing these calculators can do. If you have, so click y equals, top left button. If you have a function written in your y equals table or your y equals window, then you can do this. Click second and table. So you have to click the buttons in that order. The second key is basically like a shift. It's like shifting to capitalize something. So we're kind of shifting and then hitting the graph button, but when you're holding the shift in, it actually makes it select table instead. So that's what the blue button does. So we're hitting second table. And what do you think we're looking at now? Look at this. This is a table of X values and Y values. It looks something like this. So it'll have a bunch of X values, -4, -3, -2, -1, and then the corresponding Y values. So I want somebody to help me out. You can scroll up and down on these. You can scroll up and down. So I want somebody to scroll on this table and tell me when X is 17. When X is 17, what's Y? McKenna, you're super fast. 209. Does everybody see that? Can you scroll down to 17 and see that the Y value is 209? Okay, so how can we use this table to find our roots? We find the places where Y is 0. So you're scrolling up and down. You're looking for places where Y is equal to 0. So the X values that correspond to those places are -2 and +6. So the method we're using is exactly the same as we did in example 2. And notice we got the same answer because we're doing the same problem. We did it once with a graph and now we did it once with a table. We got the same X values. So our roots are -2 and +6. Does that make sense?
Yep.
All right, we're going to do one more example. And it's going to fit right here. We're going to call this one example 4. And it says, find the roots of 5x squared minus 3x minus 4. So we're definitely going to use our calculators on this one. I'm going to give you a minute to get this written down. I see some people are still writing. By the way, if this example isn't in your notes, you don't get full credit for your guided notes today, so make sure you write this example down. We need to type this function into our calculator. So we hit the Y equals button, and there's already something written in there, so we have to clear that out. So the function that we put under our y equals before, we have to erase that. So erase everything from that page and start fresh. We type in 5x squared minus 3x minus 4. And then when you're done typing, double check it, make sure you typed it right. Then you can hit graph. If you're looking at a standard window, your graph should look kind of small, actually. It's like really skinny. Kind of goes like this, right in the middle of your page. Can I get, can you guys nod if this is what your graph looks like on your screen? Yeah? So most students are looking at a standard window. It's kind of hard to tell what our roots are when we're looking at a window this small, or I guess this far away. So what we want to do is we want to take a closer look. We want to zoom in. So click zoom, which is in the top middle. Click zoom, and then go down to zoom in and hit enter twice. That helps us see our roots a little better, right? So now we've zoomed in and it appears that my graph looks something a little bit more like this. Like that. Looking at this, can you estimate what these x values are? Like how about this one? What does that one look like it is?
Looks like a 4.
Well, see that little hash mark? That hash mark is 1. So it's just slightly to the right of 1.
Wait, what?
So can you see my screen okay?
Yeah.
This value right here is 1. So what would this value be equal to? Just slightly to the right of it.
Like 1 point something.
Yeah, like 1.2-ish or something like that. Exactly. If we were trying to use our graph method that we've been using so far, we would have to estimate this value. Well, this is algebra, and we like to be more precise than that. So we don't want to just guess what this is. We don't want to guess what our intersection is. So by actually looking at it on a graph, we can tell that this is not a whole number, but we can't tell exactly what it is. So this method's not working for us right now. Let's try the table instead. So go to your table. How do we do that? We hit second table. It's the top. Let me erase this and write it again. It's this button, second, and then the top right button for table. So second table. Absolutely. So scroll up and down. Miles, did you make that pass?
Yeah, I'm making it.
Okay. I'll approve as soon as I see it pop up. All right. So back to what we were doing, though. We were looking on our table. Does anybody see any places on our table where our y value is equal to 0? No. Well, of course not. Think about it. The places where our y value is going to be equal to 0, you're good, Miles, are going to be here and here. These are numbers like 1.2 and negative 0.5 or something. 1.2 is not going to be on this table because look at your x values. These are all whole numbers. See that? They're all whole numbers. We won't get decimals on this table. That means the table's not going to work either. We have to learn a third method, a new method that helps us calculate the zeros. This is going to look really weird, but as soon as you practice it a couple of times, I promise it's not that bad. You do have to practice it a few times though, okay? So don't get frustrated if you can't figure it out right at the start. Here's what you do. You click second calc. We are going to calculate our zeros. Remember, zeros are roots. They mean the same thing. So click second and then calc, and then go down to the 0 and hit enter. But don't hit anything else after you hit enter. Just sit here for a second. I want everybody to catch up. After you click second calc 0 enter, you should see a screen that says left bound on the bottom. Do you see that? Does it say left bound? Nod if that's what you see. If that's not what you see, shake your head. Here's what you're gonna do. This is gonna be a 3-step process. Your calculator is going to say left bound, and then right bound, and then guess. Your job is to use your arrow keys. Let's say this is the 0 we want to find first. We're gonna do this one first. When it says left bound, you have to use your arrows to scroll over to a spot that's left of this 0. So hit your left arrow, I don't know, like 10 times or something, until the little X is to the left of the 0 that we want to find, and then hit enter. As soon as you do that, your screen will say right bound, and then you're gonna scroll to the right a little bit and pick a point that's to the right of the 0 that you wanna find, and then hit enter. Then your screen will change and it will say guess. It wants you to guess. So then we're gonna put the X as close to the 0 as we can to see if we're gonna kind of try to tell the calculator where we guess the spot is. And after you hit enter there, then it gives you your 0.